Pre-AP Calculus, we're in note 7.5, looking at another example. For each of the following, state the reflections and or shifts, that's translations, that would make the graph of the mother function, be careful, of each of the following. Then state the change that we made to the coordinates of the mother function to obtain the graph of the given function. Then state the domain and range of the given function. I think I forgot to do domain and range. Oh, bother. Oh, well. So let's first of all, let's check this out. Is this written in the right form for us? Our base is bigger than 1. Great. Coefficient of x is not 1. Not so great. So we are going to factor a negative out of the exponent. And that way we can follow the coordinate rules that we've been using for this whole year. So as far as transformations go, there's going to be a horizontal reflection and translating left 3. Horizontal reflection because we're multiplying the inside by a negative. And we are translating left 3 because we are subtracting a negative 3 from x here. Vertically, we are going to translate down 2. And then if we just kind of follow the steps that we had on the front, which was this here, find the location of the asymptote, giving justification. So h has a constant. -2. Therefore, there's going to be a horizontal asymptote at y equals -2. Let's graph that little fella. All right. Then we want to state whether the graph is going to be above or below the horizontal asymptote, and then if it's and if it's going towards or away from it. So in this case, a, which is what you're multiplying by the base, is 0. Therefore, h is above the horizontal asymptote. Then we want to figure out what c is. C is negative, it's less than 0. So h of x is going toward the horizontal asymptote. I'm going to mark each of these things on my picture. The graph is above, and we are going toward the horizontal asymptote. Let's put this right here. And then 4, let's take the main point, 0, 1. That's the point that we've been keeping track of. Let's see where that is going to move using the coordinate rule that we can get from this stuff up here. So we got the original ordered pair. Horizontal reflection means we're going to change the sign of x. Translate left 3, we're going to subtract 3. As far as the y value goes, we're going to translate down 2, so it's y minus 2. If I change the sign to 0, it's still 0. Subtract 3, it's a -3. And then here, 1 minus 2 is a -1. Once I have that point, -3, -1, that's my starting point for this. It's above the horizontal asymptote, which I expected. As I go to the right, it's supposed to grow towards it. So as I go to the right, every time I go to the right one, the distance between the point that I'm drawing and the previous point is half the distance to the horizontal asymptote. As I move away, if I move to the left, the distance here is going to double. So it's 1, then it's going to be 2, then it's going to be 4, then it's going to be 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's what my graph's going to look like. Now, a question that you may be asking yourself, what if the base wasn't 2? Let's say the base was 10. Once this point's on, then if I go to the right, the distance is 1/10 of the way. If I go to the left, the distance is going to be 10 times more. If the base is 3, I go this way, and it's going to be 3 times the height. And then 3 times more would be up to 9. To the right would be 1/3. So go ahead and stop this video. Do the next 3 problems, and then check your answers. Pause it. Do it. All right, here's number 2. I did a lot of copying and pasting with this stuff. Hopefully I changed all the numbers correctly. Here's number 3. It did even more copying and pasting this time. And then here's number 4. A lot of copying and pasting. Hopefully I changed all the numbers. That completes the notes for 7.5.